Let me introduce myself. My name is Kevin Kempter. I work for Consistent State, Postgres professional services company. And today I'm going to be talking about Postgres monitoring. First, let me give you a little bit of background, why I'm teaching the monitoring class and why I structured it the way I did. So when I was first getting into Postgres, I would go to a lot of the conferences, and every time there was a monitoring talk, I was there because I wanted to know, how do I monitor the tool or the database? And often the talk would be, hey, we have this great tool and we want you to use our tool. So the class was all about the tool. Or we have this great web portal that helps you monitor. You should use our web portal. And I usually walked out early because the web portal idea is a great plan and a tool is a great idea. But I wanted to understand underneath the covers, what should I be looking at and why, and where's the data? Where's the database metrics and where's the system catalog data and how can I leverage it? So what I've done is put together exactly that. We're gonna do a quick walkthrough of the system catalogs, the system views, if you will, and I'm gonna talk to you guys about where those views live and what they look like and how you can leverage them. I will talk about a couple of different tools that I like to leverage or we like to leverage at the company for our clients, but basically it's going to be a walkthrough of the system catalogs. So just to give you a heads up, if that's not what you're looking for, you're probably in the wrong talk. But if that is what you're looking for, then you're in luck because that's what we're going to talk about. So real quick, a little bit of background on us as a company. Consistent State, we are in the midst of a major shift, if you will. We're flipping the company upside down. In the past, we were a Postgres consulting company, and we also offered managed services, and as a footnote, by the way, we'll do training too, which seems to be the mode for most companies in this field. We're flipping it, so training is one of our major pillars. And we're not going to really engage in the typical training. It's not like we're doing here today, hey, fly out to Denver for a week and we'll do an admin course. And when we talk about streaming replication, it's a 45-minute module and we cover the fastest path to get from point A to point B, let you guys test it and then move on. This is true online training, multiple choice based. The framework we've engaged with has done all the brain research or the science research around how people learn. So it starts throwing you questions from the get-go and figures out which questions you're getting wrong and starts to present training based on those wrong questions. And it's also got lab modules that you download and actually do some hands-on. That plus the fact that we truly exhaust the topic. So for example, we've just rolled out a streaming replication course. And instead of, here's how you get streaming replication up and running, we do that as the first module, but there's like 15 modules. So we also cover cascading and synchronous versus asynchronous and log shipping and different debugging scenarios and so forth that truly exhaust the topic. And plus, once you sign up for a course, you get access to it for a year, for 12 months. So you can come back and retake it, you can come back and review it as often as you want for a year. So there's my shameless plug. We are in the midst of trying to revamp the company, if you will. We do have some managed services as well. One of them is monitoring and feedback service, and we leverage a significant amount of what I'm going to cover today in this monitoring and feedback service, where we basically put some scripts on our client servers. We will gather system catalog stats, and we also gather, unless there's issues with security or HIPAA compliance or what have you, we also gather the Postgres logs, and we will do both log parsing and basically generate RRD charts based on what we're seeing in the system catalogs. And as DBAs, we go through that data daily and start to give our customers some feedback in terms of, you know, hey, you should be concerned about this, or, you know, in 6 months, based on our current trend, you're going to be out of space for this particular table space, so on and so forth. We also have an enterprise backup and recovery service where we do backups into the cloud, point-in-time recovery based, and we allow our customers to pop us an email or pick up the phone and say, I need a full recovery, or I need a PG dump of this particular table, or what have you. And the system does test recoveries every time it does a backup as well. And then we also have a rapid review, which is sort of a glorified health check. It's about a 2-week process. We go real deep and come back to our clients with, here's the state of your systems, and here's what we recommend you do moving forward. Of course, we do consulting. That, up until today, was our core. We're trying to shift that to training being our core, but nonetheless, we still do traditional Postgres consulting. So that said, we'll jump into monitoring and stats. I'm going to talk a little bit about the Postgres database logs, and there's a variety of ways where you might want to monitor the logs just to make sure that you don't lose information. Likewise, we'll talk a little bit about OS process monitoring, the Postgres statistics collector, and then we'll get into the views, the system views. I'll throw out just a handful, not significant amount, but a few useful queries that I think are really beneficial that hit those system catalog stats. And then also a couple of tools that we've run across in the past that we find very helpful. One of them is a log parser, which we'll get into, that's quite helpful. Likewise, if anybody has any questions, don't wait to the end. Feel free to stop me midstream and we can, yeah, go ahead.
Will the slides be available after the presentation?
They will. Is there somewhere I can email the slides?
Yeah, I'll provide it.
Oh, great. Yeah, absolutely. So, database logs will contain a number of different bits of information. One is that we will get general log information, and you'll have the tag log in uppercase with a colon, and then it'll tell you notices and just informational. Also, you can get log entries for long-running queries and so forth. You'll also see in the logs that there's either the keyword fatal or the keyword error, and that'll allow you to see when there's actual errors taking place. And the errors will generally fall into 2 categories. One will be things that you really care less about, like the user Scott doesn't exist and somebody's fat fingering their username, and other things that are critical that as a DBA you do want to know about. And then finally there's hints as well. So for example, if you set up your checkpoint warning appropriately and you're doing more checkpoints than that checkpoint warning within that time frame, it will actually start to give you not only log entries that say your checkpoints are occurring too frequently, but it'll also give you some hints. You might want to, in this case, consider increasing your checkpoint segments. I've seen the logs be monitored a number of different ways. One is, at the tail end, we're going to talk a little bit about a tool called PG Badger, which is a log parser. And PG Badger will, in fact, pick up logs, entries, and warnings, and errors, and so forth. And there will be a page that shows you sort of the top 10 list. And that's a great way to look at it. It's a great tool to keep tabs on what's going on in your logs. But also, I've seen a number of shops that will crank out just a simple shell script and put it in cron and parse the database log. It always parses, say, yesterday's log, looking for these particular components. And then when we see things, for example, the user doesn't exist, we can start to filter those out. And after you fine-tune that script over the course of a couple months or so, you end up with an output that is directly relevant to the things that you really want to know what's going on with your database. Also, as a Postgres DBA, you're going to want to be doing some OS monitoring. And our primary tools are PS and TOP and IOStat, NetStat. So PS, of course, will give us a listing of the current running processes. Here's an example that shows us all the processes that are running on the current database server. If you note that second one from the top, if in fact the database was started with -D and give it the full path to the data directory, which will happen if you run it with PG control with the -D, or if you use the root service command, it also starts it in this fashion. So if somebody points you to a database server and says, something's wrong, and I don't know where the database lives, and I don't know where the data directory is, but fix it, then you can look at PS and usually figure out where that actual data directory is. This is great if they've got a setup where you can't run PSQL because they don't have trust access for local connections. You can't even connect to the database. Therefore, if you find the -d, then you can go find that directory. You can modify the pghpa.conf file to give yourself that trust access, do a simple reload, and now you can do your debugging and then back that out when you're done. If, of course, you do have access to the database, then you could just connect and say show data directory, and you could also find the data directory of the running database. This will also show us all the other processes, the background writer and the checkpoint processes and so forth. It'll also show individual process lines for each top-level query that's running within a session. And there's a number of ways that you can kill queries. One of them is just to do a kill on the process ID. Side note, never, ever, 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 ever do a kill-9 on a Postgres process. In 99.9% of the cases, it will bring the database engine down. And it's intentional, because if the Postgres engine detects that that process has simply gone away because you did a kill-9, there's a data integrity issue, and the database engine can no longer guarantee that there's data consistency, so it will sort of initiate a self-crash. So when you restart it, it will force it to go into recovery mode and validates its data set against what's in the write-ahead logs, and therefore guarantee data consistency for you. Also, we can look at top. So if everybody's complaining, I can't even connect to the database, everything's falling apart, blah, 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 top will give us a good feel for, you know, what's actually hogging the most resources at this point in time on that system, what does our overall load average look like, and so forth. Also, IOStat is a great tool if we figure out, or if we get some hints as we're doing our debugging that maybe there's an I/O issue. The database server itself isn't really going to give us a good snapshot of what our I/O channels are looking like at any given point in time. If we run IOStat, in this case 2-5, which says, I believe it's run it 5 times, 2 seconds apart in between for each time, this will give us some real indicators of how flooded our I/O channel might be at any given point in time. Now, it's going to show you information for every disk device or every volume on the system. So you're, as a DBA, you're going to have to know which volumes are associated with the database. In most cases, on most database servers, all of the volumes are associated with the database in some fashion. So you need to know which volume has your transaction logs and which volume is which table spaces and so forth. Here's a couple of examples or a little further information on the IOStat device stats. So the percent user value shows us the percentage of CPU utilization that's occurring at the user level. And of course, we have the system level and we have the nice level, which is the percentage executing at the user level with nice priority. There's also the I/O wait that shows us the amount of time that the CPUs were idle because they're waiting on an outstanding I/O request. This is a key indicator. If we have a significant amount of I/O wait, or we're seeing an increasing amount of I/O wait over time, then the system is actually waiting on I/O requests, and you've probably flooded your I/O channel, which of course gives you a wealth of information, or a great starting point, if you will, in terms of if I know my system's flooding my I/O channel, now I can focus my debugging exercises or efforts on exactly that, instead of continuing to look at you know, what else might be wrong. Is my buffer pool not big enough, and so forth. All those might be related, but if my I/O channel is flooded, that gives me a limited set of things to look at to try to fix the issue right now today, assuming this is on a production box, and then worry about what's our long-term strategy, which might include increase of memory or increased buffers and so forth down the road. But usually the issue is we have a problem and we need it fixed, and we need it fixed now. There's also the percentage of time spent in involuntary wait by virtual CPUs if we're doing virtualization. There's a percent idle, which is exactly that. It's also going to show us the transfers per second that were issued per device, the blocks that are read from the device per second, the blocks written to the device per second, and then the total number of blocks read and the total number of blocks written. If you run, say, an IOStat 2.5 or an IOStat 5.5 or something like that, these particular parameters, the blocks read and the blocks written and the read and written per second, will give you an indication of is my I/O getting worse, or is it getting better, or is it fairly constant? And that's a great indication of trying to figure out, do I have issues at the I/O layer or the I/O level within my Postgres database. Here's an example. So if I ran IOStat 2.5 and I got this output, the total blocks read are 180K in this example, and the total blocks written were 145 meg. I'm sorry. So if we were to go and look at the blocks written and the blocks read and tally up these values and look at what's changing across these 5 outputs, if you will, from the IOStat command, that's exactly what we would be able to figure out. This is by no means a flooded I/O pipe, but you can see how it would give us a feel for what does our I/O look like overall at the system level. NetStat will also help us if we're having network connection issues. This is an area that myself and I think a lot of DBAs don't get really deep into. This is when you call the SA and say, hey, dude, help me. Or if you've got a network administrator. However, you can do some basic debugging by running NetStat. For example, on that bottom line, if we're grepping for PGSQL and grepping from the output of grepping for listen, that will only show us the PGSQL lines, and we'll be able to see what ports they're listening to. This is good if, for example, somebody fired up a database on a non-standard port, and they also chose not to add, say, PG port as an environment variable for the Postgres user, and you've been thrown into the deep end and you have no idea how to connect to this database, but you see it running, and to boot, you can't figure out where the data directory is, so you can't go grep for the port out of the config file. This can sometimes save you from having to pick up the phone and say, help me. So Postgres has what's referred to as a statistics collector. It's a set of parameters that allows the database to gather real-time statistics and write them to the system catalog tables. Postgres does 2 things with these stats. One is if you're in a current transaction, there's a set of tables that within your transaction the stats are written to, and those stats are not updated in the system catalog views themselves until you commit your transaction. That said, there's a separate set of tables that it does stage them in real time as you're walking through your transaction. So if you needed to see either the complete total picture of all stats for a particular parameter, or you only wanted to see the stats related to your transaction, there's a separate set of tables you can look at, and I believe we touch on those a little later. However, there's a number of parameters. The track activities, this one enables collection itself. By default, it's turned on. There's a track activity query size. The default is 1024. It's the number of bytes reserved to track currently executing commands. In particular, when you're looking at the system view pgstat activity and you're looking at the actual query that's being run, you'll only see 1024 characters. So if somebody's launching a 8,000 character query, you're not going to see the entire query. It's going to be truncated. You can change this and see that, but there is some overhead with increasing this. So increase this cautiously and watch for performance issues if you do so. There's also a track counts by default. This one is on, which tracks the collection of statistics in terms of auto vacuum counts and so forth. And then also there's a, I believe I have a duplicate in there. So the query and statistics collector also has the track IO timing. By default, this one's off. It's not going to track the IO timing in the database, mainly because it does require a fair amount of resources to do so, and on a very, very busy database server, you will see a noticeable performance hit if you turn this on. If you have a fairly small database and mediocre traffic, you're probably not going to notice it. But if you've got a big boy production database and you have a lot of traffic on that database during core business hours, this is going to impact noticeably the performance of the system. I generally leave that one off. I haven't found scenarios where I really need to come back and turn on track I/O timing, with the exception of we get into these scenarios sometimes where everybody's scratching their head and they just can't figure out what the heck's going on. Every day at 2 o'clock, the database is just falling over for 45 minutes and then it's fine. We can turn this on, and I have done so for, say, a 24-hour period or a 48-hour period. So we can grab those stats and try to help us figure out what's really going on. Obviously, there's going to be a performance hit, but we're kind of in crisis mode anyway, so the more info we can gather, the better. There's also a track functions. There is no default, meaning it does track the functions. This will track function call counts for the time used within each function, and also an overall time for functions, meaning if a function calls other functions that then call other functions, it tracks the end-to-end round trip time for the top level function as well as the individual times for each function. It's nothing more than timing of how long we spent in the functions, which can give us some great visibility into, do I have some really poorly written functions that are called, 820,000 times a day that are causing us major performance issues, and it's not really a database issue, but it's a poorly written function issue. So that said, we'll jump into the statistics views a little bit. Any questions so far? Thoughts, comments? Okay, so the statistics views, the first one is PG stat activity. This will be the view as a DBA that you probably spend most of your time looking at. This view shows us one row per server process. So if, application A connects to the database and starts launching queries, you're going to have one row for application A. If, John Smith connects and starts running queries, you're going to see one row in this table or this view for John Smith. That said, this particular view will show us not only the queries that are actively running and all the connections that are currently connected to the database, but it also shows us the state. So for example, I could log into the database and I could execute a query, and then I can sort of go idle, for lack of a better term. This particular table, the row for me, will show that I am in fact idle. If we look at the state, the state would be idle, and I don't know that we have the whole picture there. I think we've truncated it slightly. However, there's a state column, and the state would show idle. The state change would show the last time that this particular connection had a state change, meaning I went from actively running a query to idle, or I went from idle in transaction to issuing a commit, meaning I had done a begin and I executed a couple updates and then went idle. Therefore, I rolled into an idle in transaction state, and then when I issue the commit, the state will change once again. There's also a transaction start and a query start and a back-end start. These timestamps are very helpful. For example, I could come in and say, look at the query start, and I can figure out what's the longest running top 5 queries or sessions that I have in terms of queries specifically. I can also go to the back-end start and I can ask, what are the top 5 sessions that have been connected for the longest amount of time? If I've got sessions that have been connected for days and they've been idle for days, then maybe I want to think about killing those connections. It's also got some useful information about the connection itself. It shows us the database ID, which is the OID of the database that session is connected to, and also the database name, the dat name column. It shows us the PID, which is the actual OS process ID, the Linux process ID So if I wanted to, I could just do a kill on that process ID. There's also some database internal functions that allow me to cancel that PID, that process ID, or to terminate that PID. And there are two different functions. One of them says, when you get a chance, clean it up nicely and cancel this process. And the other one says, be more forceful, try to actually make this process go away, but still do the proper housekeeping so the database recognizes that data integrity is still intact. Also, it shows me the user sysid, the OID of the user, and also the username that's connected. If, in fact, it's set, it'll show the application name. For the most part, unless you go through the steps to set it, you're only going to see this set for things like PG dump and PG dump all, and if you're doing a PG-based backup and so forth, because the Postgres utilities will, in fact, set that application name. Also, it shows me the client address. Sometimes this will show up as a -1 if it's a local connection, but if I've got multiple users coming in from multiple different desktops and multiple external servers and so forth, I'll actually get the IP address that they came from. So if somebody's causing us major grief because they keep launching this giant query that brings the database to its knees, we can track down at least the workstation that it's coming from. And also we can see the port that it's coming from as well, meaning the client port. There's also a table called PG Stat Archiver, and this, it only contains a single row at any given time. I'm sorry, did someone have a question? I thought I saw a hand. I guess not. This has information about archiving. So if I turn on wall archiving because I want to do point-in-time based backups, or I want to ship my wall files to a standby for streaming replication so that that standby can make sure that if it ever gets too far behind, i.e. the transaction logs on the master have already wrapped, and once it finally gets access to the transaction logs, it figures out that my data is gone, then it will revert to wall shipping. If I turn on wall archive for any reason along those lines, I will have a line in this table or a row in this table at any given time with the latest stats or the current stats. It's going to show me a cumulative archive count, meaning the number of walls that have been archived either since I initiated the database or since I did the last stats reset. One note about stats reset is most of the tools out there, and even the shell scripts that we use as part of our managed services, every time they pull the stats, they'll do a stats reset. That way we get actual numbers. So if let's say I've got a script that's pulling underlying system catalog stats every 15 minutes. If we do a stats reset every 15 minutes, then we can take those numbers as is and run them through an RRD tool, and we can graph actual numbers or actual counts of what's going on with these various system catalog tables. And it gives us a very clear, concise picture of what the database is actually doing. If we don't do that, then we have to come back and figure out the diff, if you will. For example, if we're looking at the number of wall files that have been archived, if I pull it at 8 a.m. and it's 1,000, and then I pull it at 8:15 a.m. and it's 1,500, my script has to have that logic to go back to the last snapshot and minus the 1,000. Therefore, in the last 15 minutes, there have been 500. Whereas if I'm doing the stats reset, it's only going to show what happened since the last reset, meaning it'll pull 1,000 at 8 a.m. and it'll pull 500 at 8:15. Likewise, there's a last archived wall file. It basically gives me the name of the last archived wall file. It shows me the timestamp of the last archived wall file. It shows me a failed count. It shows me a last failed wall file and the last failed time. The failed columns in this table are absolutely key. If you're going to be monitoring your database and you're doing any sort of wall archiving, there's always the possibility that your archive command begins to fail. Let's say, for example, you have a standby and you want to make sure that your standby has a backup mode, meaning I'm going to do wall archiving and let my standby revert to wall or to log shipping in order to stay in sync if in fact it gets too far behind from the master. And let's say also I decided I don't really need these files locally, so my wall archive command is going to be an rsync that ships that file straight over to the standby. If that standby ever goes down, that rsync is going to fail, and what the database is going to do is it's going to keep that file in your pgxlog directory, and it's going to let those files start to stack up and stack up. And we've seen multiple times scenarios where we get a call one morning and they're like, well, our file system filled up, so please help us. Whereas if you were monitoring this table, and in particular monitoring your failed count, then you would have gotten an early warning that says, hey, the wall archives are failing. And that way you can catch the issue long before your file system fills up and your database falls over. And of course it's going to fall over at the worst possible time, during business hours at your peak activity time or what have you. There's also a table called PGStat BGWriter. And this table, again, has a single row at any given time, and it gives us information about the background writer and foreground checkpoints. So it's got a checkpoints timed column, which is the number of scheduled checkpoints that have been performed. Meaning, if I schedule my system with a checkpoint timeout value in my PostgreSQL.conf file to 5 minutes, let's say, which is the default, then I should get a checkpoint time count every 5 minutes. If I'm seeing it more than 5-minute intervals, that means I'm running checkpoints more than what I scheduled the system to run, and therefore I should be trying to figure out why. There's also a checkpoints requested, and the reason that counter gets bumped is either somebody logged into the system and ran the checkpoint command, or my transaction logs wrapped back to log 1. So by default, Postgres gives you 3 transaction logs or checkpoint segments. And once log file 3 fills up and it gets ready to rotate back to log 1, before it overwrites log 1, it forces a checkpoint, again, to guarantee data consistency. So that's when the checkpoint's requested value will get incremented. There's a checkpoint write time and a checkpoint sync time that gives us the total amount of time spent writing checkpoints versus the total amount of time spent doing the checkpoint processing in terms of syncing the dirty pages to disk. Also, it's got a buffers checkpoint value, which is the number of buffers from your memory buffer pool that have been written during a checkpoint. There's a buffer clean and a max written clean. The buffers clean being the number of buffers that were written by the background writer, and then also the max written clean, and this is actually a fairly key indicator, the number of times that the background writer woke up and wrote the maximum number of pages it was allowed to write, and then had to go back to sleep even though there were more dirty pages that it could have written to disk. So, for example, the goal with the background writer and the checkpoint system is that the database, any relational database, has to run checkpoints on a regular basis, which effectively sync everything in memory to disk in order to have a reference point to guarantee data consistency. The problem is it's a necessary evil because checkpoints are foreground processes, and checkpoints can impact our performance in a negative way, in particular by flooding our I/O pipe. So the background writer was introduced to come along in the background and simply sync dirty pages to disk. The background writer has a couple of settings. One of them is BGWriter LRU max pages, which says this is the maximum number of pages you can write every time you wake up. And there's also a sleep time. By default, it's 200 milliseconds. So if, in fact, the background writer wakes up every 200 milliseconds, and it's allowed to write, let's say, 150 pages to disk, and every time it wakes up, it's bumping up max written clean because there were 200 or 300 or 400 dirty pages in your buffer pool at that point in time, but it couldn't write them because it reached its max. That's a key indication that maybe you should be tuning the background writer or spreading your checkpoints out a little further so you can try to reach that balance. And the balance we're trying to reach is that we want to run a checkpoint on a regular basis, but when it's time to run a checkpoint, we want there to be as minimal work to do as possible. And therefore, we want the background writer to do the bulk of the work. But we want to do it in such a way that we don't shift the problem, i.e. flooding our I/O pipe from the checkpoint foreground processes to the background writer. So it's a fairly delicate balance, but these values, this table in particular, will help us monitor what's happening in checkpoint background writer land and help us figure out, are we truly tuned as well as we should be? There's also a buffers backend, which is simply the number of buffers that were written directly by the backend. The number of buffers that were written directly by a backend. This happens because, let's say I've got a 4 gig buffer pool and somebody comes along and runs select star from the customer table, which has 287 columns and 3 of them are varchar 2000s and they're always full. So I'm going to basically flood my buffer pool, and it's going to force any dirty pages at runtime to get synced back to disk. This is important to keep an eye on because that's a classic case of a significant I/O issue that's fairly difficult to nail down because it's usually not a routine thing that happens every time we do a checkpoint, per se, or it happens every 30 minutes, or it happens, at 2 o'clock every day. It's really random because it's dependent on the queries. So if we're monitoring this can help us figure out that we are, in fact, it's not going to point us to the queries, but it will show us that that's taking place. We're actually flooding our buffer pool, and we're forcing those dirty pages out to disk, and this will give us not only the number of buffers that were forced out of the buffer pool and written to disk at query time, but it also shows us the back-end fsync time. So between those two, we can figure out to the extent how big of a problem this is. And then also it shows us, and this is a static value, meaning as opposed to being a cumulative counter, this is the number of buffers that are allocated at any given point in time. So if I've got a 4 gig buffer pool, and we take 4 gig by, the size of our page, which is probably 8K, then we can figure out, okay, based on that, let's look at how many buffers are allocated at any given time versus how many buffers would fit into a 4K buffer or a 4 gig buffer pool, and that'll show us, is our buffer pool being leveraged properly? Is it maybe too big, or is it potentially too small? And this can help us do some performance tuning over time. It's not necessarily a problem per se. It might be one of those issues where our buffer pool is too small, but the OS cache is largely making up for it. And that's okay, but nonetheless, this can help us figure out, with respect to checkpoints, the background writer, and the sizing of our buffer pool, are we tuned well? Also, there's a table called PGStat database. This has one row in the view for every database in the system. It basically shows us the database ID and its name, the number of backends concurrently actively connected to this database, and then also a number of parameters or columns that show us cumulative values against the database, the number of transactions that have been committed against this database, the number of rollbacks, the number of blocks that have been read versus hit, the blocks read meaning the number of times that the system had to go to disk or go to the OS and request a page off disk in order to pull it into the buffer pool, versus the blocks hit, which are the number of times that the page it was looking for was already found in memory. Of course, with those two values and the database name, we can calculate a hit ratio per database. And if our hit ratio is anything less than about 98%, then we probably have some tuning to do. It also shows us the number of rows that have been returned, fetched, inserted, updated, and deleted. Again, cumulative values against each particular database. It also shows us the number of conflicts, which is the number of conflicts in terms of streaming replication. So a conflict would be, for example, I've got a standby and I'm querying the standby and I'm actively querying a table that just got deleted on the master, and now that delete comes across, but I'm still running a query trying to access that table, my query is going to get canceled because of the conflict. There's a handful of conflict categories, and this will show us basically just a count of the conflicts against that database. It also shows us the number of temp files, and in terms of bytes, the amount of data that has been leveraged in temp files. There's a block read time and a block write time, the last time the stats were reset, and so forth. I'm running short on time, so I'm going to speed it up a little bit, but let me know if you have any questions and we can slow down. This particular table is used heavily. This has one row for every table within the current database. So if I'm connected to the Postgres database, this view will only show me tables within the Postgres database. And it shows me things like the number of sequential scans against a given table and the number of rows that have been inserted versus updated and so forth. I can get a pretty clear snapshot of the activity against any given table by looking at the PGStat all tables, or this table actually has a PGStat user tables and a PGStat system tables version, which show exactly that, the user tables versus the system tables or all tables. I usually go after the PGStat user tables because that's really where I'm looking for monitoring to happen. It also shows me information about when vacuum was running versus auto vacuum and some statistics about how often that's taking place. There's also basically verbatim the same thing for indexes. The column list is shorter, meaning we can only look at the number of times the table was scanned versus the rows that were read versus fetched for an index. We also have stat.io all system and user tables. This one is different in that it shows me IO particular statistics. The number of blocks read versus the number of blocks hit. Likewise with the PGStat database view, I can use this and I can figure out hit ratios per database if in fact that might be part of the issue I'm running up against. Also, there's a number of index IO and toast table IO statistics in these tables. Same thing for the indexes. There's a stat.io version of the table for indexes. There's a stat.io all and user and system sequences that gives me sequence information. There's PGStat user functions. These are the function counts I was talking about earlier. There's also a PGStat replication table, which will show me one row per wall sender process. And this will give me some visibility into activity for streaming replication and how far behind the master might be from the slave and so forth. Vice versa. Also, there's a PGStat database conflicts table that'll show me a little bit better or more visibility information-wise around conflicts that are taking place from a streaming replication perspective. Well, here's a handful of useful queries. So the first one is just, let me see all my current connections. Select star from PGStat activity. Or if I add where waiting equals true, I can see all the queries that are actually waiting on another query. The top 3 longest running queries I can get by selecting now minus the query start time from PGStat activity. Here's a query, and I will upload, or I'll send you guys the slides. This query is really helpful in that it will show me the root query that another query is waiting on, which is sometimes very difficult to figure out. If I hit PGStat activity for my waiting queries, it only shows me the queries that are actually waiting. It doesn't show me the blocker that everybody is waiting on. This will show me the blocker. We can get table hit ratios and database hit ratios by basically grabbing the sum of the blocks read versus the blocks hit and then doing the calculation. We can get the sizes of all databases. We can check hot standby lag, all by hitting these system catalog tables. Finally, there's a set of tools that we like to use. PG Badger is a great log parser, and it'll give us a real good visibility into what's going on in the logs themselves. Here's a couple examples of a PG Badger report. It'll show us the SQL traffic. It'll show us the slowest individual queries. It can show us normalized queries from slowest to fastest. It usually does top 10, but we can tweak that. It gives us visibility into temp files. And there's also a tool called PG Clue, which does a lot of what I've been talking about in a GUI format. There's a collector component, and then there's a report builder component. So it's always trailing indicators, but it will show us our hit ratios, the background writer stats, replication lag, system load, so on and so forth. So apologies for having to speed it up at the end, but hopefully it was good information. Any questions? Yes?
How do you use PG Badger on a daily basis? Do you have something emailed to you? Do you run it throughout the day?
We will generally automate it in such a way that we have a web page we go to that has, say, the last 30 days of PG Badger reports, and we'll click on the one we're interested in and walk through the data in that report. So it's always available for a rolling 30-day window. Yes?
Is there kind of a useful query for deadlocking as well as blocking that you might recommend?
We can, yeah, absolutely. There's a couple. We can query and look for the deadlocks that are taking place, and there's a way to go similar to the query I just showed you, where we hit the PG locks table, and we can figure out the queries involved with the deadlocks, which is, of course, what we really want to know at the end of the day. If you want to pop me an email, I will dig that query up and send it your way.
Thank you.
Any other questions? Yes?
Do you find monitoring vacuum helps, or however you categorize that useful? I mean, what is it?
In terms of vacuum, I generally go after two things. I'll monitor how long the vacuum process is running, and I can do that. There's a vacuum parameter that says if it runs longer than this many milliseconds, log an entry in the log for me. And then the second thing is, as opposed to vacuum, I'll monitor dead space in the tables. And if our dead space or our bloat space is growing beyond, say, about a 20% average for a table, or it's continuing to grow as opposed to sort of fluctuating up and down around that 10 to 20% margin, then we'll start to take action. For example, we might alter that table and increase the statistics, or maybe increase how often it will vacuum that table based on individual columns, or some other corrective action. We might cluster the table to get rid of the dead space, forcing it to be rewritten and so forth.
So some of these background processes, does it get prioritized automatically by Postgres engine, or?
So it's sort of a linked list. The vacuum process knows about all the tables in the system, and it just walks one to the next, and it runs two litmus tests. One is the number of rows that might have changed since the last time it looked, and the second one is the percentage of the data that's changed. And both of the litmus tests, or the thresholds, have to be crossed before it will either analyze or vacuum and analyze the table. So it just simply walks through, and by default you get 3 of them, so there will be 3 vacuum processes at any given time walking through that linked list. Any other, yes?
In your monitoring daily activity, what percentage do you use PG Clue, and what percentage do you use, say, other scripts that you depend upon daily?
We usually look at PG Clue as the early warning indicator of if we need to dig deeper. And then we use the other tables when we need to dig deeper. That's generally how we roll. Is PG Clue is a nice GUI. It's easy to look at the graphs and see if there's some spikes that we care about. And at that point, we start digging into the data. Yes? We have used Nagios. Nagios is great. It's a classic RRD tool. We've used Nagios for our monitoring under the covers, but we only do it when we go into a client that is a Nagios shop, because Nagios is a fairly hefty tool, and we don't like to bring in hefty tools just because we like that tool. So if they have knowledge as a client of Nagios and they're leveraging it, we'll plug right into it. But otherwise, we tend to stay away from it because of its complexity. Any other questions? Thanks, everybody. I appreciate your time.